Okay, okay. First of all, let me thank you, really thank you for the opportunity you're giving us to present our activities. I'm really glad to be here, an important international master, so related to one of the topics that we believe is really interesting for us and on which we are investing. But before going directly on the activities we are performing, we are delivering related to electrical vehicles and autonomous driving car vehicles, I would like to present you the company, just to give you, let's say, a complete overview of who we are and which are the activities that we perform. First of all, the group. Modis is a company inside a bigger group that is the Adecco group. Probably most of you already knows the Adecco Red brand. That is the most famous and the one related in particular to the outsourcing business, let's say, so to the research of personnel to be given to the companies. But at the end, the Adecco Group is a bigger constellation of companies in which there are several verticals. And Modis, inside this group, is the company that works on consultancy, mainly related to technological advanced activities and needs coming from the market. So typically for engineering and information technologies activities. We have a global presence that covers up to 20 countries with more than 500 offices and more than 30,000 consultants, associates that works on the projects for our customer. And we are distributed mainly in Northern America, in Europe, in Japan, and in Australia. What we do is to, on one side, give the services in terms of fixed price project and manage the services to our companies, but also to give our skills. So the opportunity to use the skills that are inside our companies to the customers. Automotive is one of the main fields that we follow. Of course, considering that I'm talking from Italy and I'm today representing Modis in Italy, I need to give you a leader presentation of Modis in Italy. And here you can see the distribution of the offices we have in Italy. And as you can see, we are in Turin and in Bologna and in Milano in particular, just because these areas are the one more active in terms of automotive. There are big car makers. In particular, I'm talking from Bologna, so Emilia-Romagna, where we have the Emilia-Romagna Motor Valley. So it's really important for us to invest in the technology related to electrical vehicles and autonomous driving system, just because we believe, but we know that actually is really interesting for automotive sector. What I will do today will be to present you two projects, one of which ended in the half of 2020, that is called Tenvain. And as you can see in the next slides, talks about autonomous vehicle, but also electrical cars, and in which, working together with other companies, we performed some particular activities that I will present you. And this is the project that ended in 2020. And then there is another one that will start next month, and that in my mind is the, let's say, the second version of the activities that we finished in the preceding project, as you will see. Few words on who I am. I'm Marco Benedetti, Head of Tech Solution in Modis in Italy. That means, at the end, Technical Director. Actually, I'm not, unfortunately, directly involved in delivery activities, in projects, technically speaking, just because my job is to manage all the activities. So I checked the possibility to invite today the technical guys that directly follow the projects, but unfortunately they were unavailable. So sorry. I will be glad to answer to your questions if you have, and of course, if I will be able to do, I will do directly today. But you can find in the slides also my email, so that if you will have questions, also in the next days or next weeks that you would like to answer to make to us, don't hesitate to send me an email, and of course we will try to answer you, also involving the technical team. So what I do inside Modis today is the management, the coordination of the internal IT structure, the process of digitalization we are with which we are going on, the technical academy, but in particular, and this is of course more related to the today meeting, the research and development activities and team, and also the technical team that makes the projects for our customers. So typically the fixed price project, related to what? To which fields? To the engineering and information technology sectors. What does it mean? Mean that we divide the market in two fields, the engineering one and the information technology. In the engineering field, there are the sectors of industry, the more important sectors for which we work are the one that you see also in the slide: automotive, avionics, medical devices, railways, manufacturing, and so on. So as you can see, there is an important role that is reached by automotive, okay? More or less in terms of activities here in Italy, the 50% of activities we perform are coming from automotive sector. So let's go on directly with the presentation of the activities of the projects that I mentioned before. Let's skip this slide, it's not interesting for you. This is, okay, before starting, just to finish the presentation of our company. In this picture, we are just summarizing the R&D projects that we are actually delivering, with which we are going on with delivery activities. That gives you an overview of the volume of activities we are performing in R&D projects. That means that are projects on which we as Modis are directly investing, okay? So these are projects not coming from the needs of our customers, but are directly sponsorized by us, typically linked also to funded projects coming from the institutions, such as the Europe or the national or the regional institutions. Tainvein was one of these projects. Tainvein is the acronym of course, an Italian title, Tecnologie Innovative per Veicoli Intelligenti, that at the end means innovative technologies for intelligent vehicles, quite easy to translate, and in which Modis is one of the technological partner of the project. It was a funded project funded by Lombardy region through the structural funds coming from the European Union. The objective was to create a vehicle with autonomous driving capability to test driving algorithms and equipment, infrastructures for autonomous mobility, and in particular involves the prototype preparation of an electric vehicle. Put in field from one of the partners. Can you hear me? Sorry, just because I see that the internet connection is not so stable.
Yes, we hear you, yeah.
Okay, okay, okay. The project, as I was saying, was developed using 2 electric vehicles coming from one of the partners, that is Share and Go, one car sharing operator that we have in Milan, and that gave us 2 vehicles to do the experimentations and to install the new onboard units that we developed. In particular, the activities that regards what Modis did were the one that you can see that are listed in the slide. So vehicle to infrastructure control and communications center, vehicle diagnostic data logger, a wireless charger system, a platooning system, and an actuator onboard unit able, of course, to actuate commands coming from the autonomous driving vehicles. But let's go in deep. This is the overview of the partners of the project. As you can see, there were 2 big companies. So Modis and ST Microelectronics, and other smaller companies, but really technologically speaking, advanced companies such as Optech, Raw Technology, and Cover Sistemi. The collaboration of the academics entities of the universities of, in particular, Politecnico di Milano and Università degli Studi Bicocca, that is the 2nd university in Milan in engineering, and as I said, of a car sharing operator that was Share and Go. One of the functions we developed was a control center. So let's say a web app able to be used via browser, but also via smartphone. A web app which functions were the real-time tracking of the vehicles. So with this control center, the operator has the complete view in real time of the fleet of electrical vehicles he has. And in particular, the vehicles are identified, okay, with graphical indicators based on the state of charge of the battery. So green up to 70%, for example, yellow from 70 to 30%, black in case of breakdown, and so on. So an immediate view of the diagnostics in general coming from the electrical vehicle, of course, with a focus in particular related to the level of charge of the battery. So also the possibility to show the status, of the charging stations in order to understand which are the charging stations available. The main objective, the main target for the car sharing operator was, of course, to make efficiency in the in the process of retrieving the vehicles from the place in which they are lived from the users, to take them to the, of course, charging station in order to have constantly a fleet of cars that is efficient in terms also of level of charge of the battery. And their, of course, aim and the interest of car sharing operators is at the end also to have an autonomous vehicle able to go directly and autonomously to the charging stations without the intervention of an operator. This is, of course, the way they see, one of the way they see to make efficiency in their business. So it's really interesting for them. And we tried to develop something considering this topic, okay? So the control center was one of the instruments we developed. Of course, considering that this was an R&D project, the TRL level of the final TRL of this development was not so high. So we are talking about a prototype. Another topic we developed inside this project was the development of an onboard unit, so made of hardware and firmware, of course, but also of electronics. In particular, one of them was for the data logging, so for the acquisition of data coming from the sensor. And I'm talking about two kinds of sensor. First of all, the one that are native in the car coming from Share and Go, so typically accessible via CAN bus. And the other set of sensors, of course, were sensors added, externally added by the consortium and needed for the autonomous driving functions, such as LiDAR sensors, radar, proximity sensors, and so on, that were added inside the car and interfaced with other kind of communication protocols and communication interfaces, such as serial interfaces, I2C interfaces, and so on. And what we did was to develop an onboard unit able to acquire data coming from these different type of interfaces and of sensors. One of the objectives of the data logger was to log the data and to register them in order to be analyzed in post-processing, so in back office. So we had at the end a memory on which we recorded in real time this kind of information, so constantly along the time. But on the other side, this data, meanwhile they were acquired, they were also sent to the control center, but also to the intelligence units with the aim of the autonomous driving algorithm. So with the aim of the definition of the actuation, so the interaction with the vehicle to apply the autonomous driving algorithm. So our board, the task of our board was to acquire data, to merge the data, to have, let's say, not only a data logging, but also a data fusion activity, and to pass them to the final users of this data. That on one side was the control center, on the other side were the autonomous driving algorithm inside the car that were hosted on another onboard unit, okay? To communicate with the infrastructure, we used several kind of communication networks or technologies. On one side, of course, we experimented the simple Wi-Fi, but on the other side, we integrated the radio that were developed by Cover Systems, so by another partner, that uses the Wi-Fi standard for automotive, so the 802.11, but related to automotive sector. So a radio, several radio were developed and experimented, and so we also experimented the communication in real time between the electrical vehicle and the infrastructure that in our case was the control center. Another onboard unit that was developed was the one related to the actuation of commands. Of course, on one side we acquired data, on the other side we interface it with several parts of the vehicle useful to command, for example, the accelerator, the brake system, the steering system, and so on. To do this, we designed a custom board that can be used again as a control board for braking system or power steering, and that uses certain type of technologies. So with several blocks, such as power supply, control unit, and so on. But the aim of this board was, of course, to send the commands to the several parts of the vehicle able to drive it, autonomously drive it. One of the other functions we, let's say, sub-project we developed inside the Tame Vein was a certain type of a platooning system, in which, again, the problem coming from the car sharing operator was to recharge the vehicles not parked at the charging stations. So this means the employees needs to go on field to take the vehicle and to drive it back to the charging station. So between the actual situation and the, let's say, most advanced one, that is the completely autonomous vehicle, we proposed an intermediate solution that we call platooning, in which the platoon system consists of semi-autonomous driving vehicles, so of several cars in sequence, where the first, which acts as a guide, is called header, with the subsequent follower, and in which the driver, so the real driver, the human, of course, drives just the header of the platoon. In this case, the technology is used, of course, both actuators and controls for driving system. In brief, what we did is summarized in this slide. The follower waits for the target point from the preceding car, calculates the inclination, and then implements the steering rotation. So since the systematic errors due to measurements and calculation can accumulate over time, there is a function of reset of reference parameters that, of course, is required. And in this case, we developed that part of the software and conducted unit tests for validation on demonstrator. In which way we performed the validation? We developed the vehicle in 1.4 scale, and we set up a model with sensors such as LiDAR and radar actuators, and a V2V communication system. And then we performed the experimentation, so the validation of the system, of course, in scale. So again, we are talking about a prototype. And the final activity, sub-activity that we conducted, in this case involving directly one of our historical partners in terms of, say, academies, universities, that is the University of Cassino. We developed together a wireless charging system, so a wireless power transfer system. And when I say wireless, I mean, of course, without cables, but also without contacts. So with an inductive, I'm talking about an inductive system with an inductive way of transferring energy, in which there are two semicores that, when coupled, form a transformer, more or less. The two semicores will be positioned under the car and, of course, in the charging station. So we believe this is one of the trends that is considered really interesting. There are several prototypes and also products actually in the market. And we are trying to develop a system that will be easily integrated in the car, easily integrated on the grid side, and of course, with which we will have efficiency in terms of transfer transferring of energy, and also with the right technology inserted in order to, for example, certify the transactions of energy. So I'm talking about, for example, the integration of the blockchain technology inside this system to trace in a trusted way the transactions of energy. So this is a, let's say, a technical, quite technical slide, just to summarize the technical specification. We are talking about related power of 3 kilowatt with an efficiency of 0.9, considering a maximum, a typical, let's say, typical air gap between the two cores of 15 centimeters. And we designed the wireless system basing on the IEC 61980. And of course, considering all the things related to electromagnetic compatibility and to type testing that we perform. Again, I'm talking about a prototype. It's not a product ready to be commercialized on the field, but we believe that it can be really useful for the car makers. So this is, say, in brief, the schematic, the electrical schema, but also two pictures that shows you the transformers at the end, the two cords. And this last part of the project is the right link to introduce you the new project we are going to deliver, to work on, starting from next month. It is called RISE. RISE means Resilient, Intelligent, Sustainable Platform for Electric Vehicles. But apart from the name and smart grid, it means that we really believe that the future will be on electrical vehicles and of course also on autonomous driving vehicles. And then we decided to invest in particular in Emilia-Romagna area, just because here we have the Motor Valley. And as I said, considering Motor Valley means big car makers, in particular for Emilia-Romagna, luxury car makers, such as Ferrari, Lamborghini, but also Ducati, Maserati, but not only car makers, also other kind of operators in terms of vehicles, such as CNH Industrial and so on. So the presence of so interesting operators of the automotive sector inside this area was an important factor for us to decide to invest on Bologna site. And so this was why we activated this project. The aim, the final objective for us of this project will be to define, to build, to construct a competence center that will be hosted in Bologna site, and then that will be totally dedicated to electronic and software for automotive, with a particular focus on electrical and autonomous driving vehicles. And this is why we invested on it. And of course, here are summarized some of the main technological contents that are essential and on which we will do an entire training path for the new resources we will insert inside this competence center. Thanks also to the contribution coming from the academics. So we will work with AutoSAR in terms of software architecture solutions, with ADAS technologies, with the aim of electrification. Cybersecurity will be really important, just because we are talking about connected vehicles. So vehicular communication protocols are also one of the topics on which we will invest in terms of training activities. And the 30 resources that will be inserted in 1 year or 1.5 years will be trained on these topics and will be the actors that will be inserted inside the International Center of Excellence that will be created. But apart from the reason for which we intended to invest on this project, of course, the project passes through some R&D activities. And here you can find the research and the experimental development activities summarized. So in terms of research, we are talking about, for example, in the context of smart grid, we will study some process innovation to be introduced in order to allow new working methods and speed up the technological growth in the sector of business services and mechatronics engines. Then we will work on also the application of design patterns in industrial standards to the procedures for creating cloud-based application with reference to specific vehicle-to-grid and vehicle-to-infrastructure applications. So, considering the word on both sides, on vehicle side, but also in particular on the grid side, surely the cloud technologies will be on the base of the development of the new technologies. So this is one of the fields on which we will invest in terms of research. Then we will also study the procedural refinement in the processing of data analysis algorithm in order to arrive to the, let's say, predictive maintenance. So what we need to do is to, in our mind, to estimate the state of health and the prediction of the residual life of the components. And then on the smart grid side, also the definition of the algorithm of the optimization of energy flows with specific reference to distributed energy storage, production and distribution system, for which sizing and management routines of storage system will be developed. The idea to, in this second project, to invest not only on the vehicle side, but also on the grid side, comes from the fact that we really believe that the, how can I say, the real diffusion of electrical vehicles will be reached only if in parallel there will be a comparable in terms of technology and growth and of let's say reach to market activities. There will be a comparable growth in the grid, on the grid side. And this passed through several things such as the accumulation systems. So in this project, we will experiment also a new accumulation system, static accumulation system on grid side that will be based on the, that will use second life batteries coming from the vehicles. And these two things, so the evolution of electrical vehicles, but also the evolution of grid with all the components needed, will be the right way to, at the end, obtain the improvement of the use of green energy, of renewable energy. And this is why we believe we are investing on it. We believe this is the future, and Europe in particular, as an important role, can be really the driver at global level of this new trend. So from the experimental development side, so activities, we will simulate in the loop manner the smart grid, consisting of passive nodes, active nodes, and hybrid mixed nodes. But also we will experiment the communication between vehicle and grid, so infrastructure, in the optimization of the algorithm according to the node operation, to the energy needs of the vehicle fleet, and finally to the priorities of the energy and power flows, of course, on the network. Consider that they are connected. And then we will go on with the development of the cloud-based service center capable of communicating with an open architecture of a battery management system to provide monitoring functions for fleet and battery packs with the possibility of assessing the operating status of the fleet in support of management strategies and enhancement of the battery pack assets. This is, as you can see, the natural evolution of the first part of the preceding project, so the one related to the control center. And we believe that there will be interest not only in operators of car sharing, but also in general on the operators that will manage the smart grid systems. And with this last slide, I finished. Of course, if you have questions, I'm here to just to try to answer to them, if I will be able, of course. Otherwise, I will just register your question and ask you to write them via email so that we can go on with the answers also involving the technical team. Thank you.
Okay, thank you very much for your nice talk, Marco Benedetti.
You're welcome, you're welcome.
Yeah, it's our pleasure to hear from your companies and what is actually done in the framework of electrical vehicles and smart grid. Also, it's very, very interesting.
Yeah, I think so. Unfortunately, Italian car makers, I'm referring in particular to FCA.
Yeah.
In his strategy in the, let's say, few years ago, didn't invest on electrical vehicles. This was due to the intention coming from the preceding managing director, let's say. But actually they decided to come back on the preceding steps, let's say. And in fact, there is an important fusion today with PSA, and they are investing on electrical vehicles. What does it mean? It means that on the Italian automotive market, we are actually probably in delay compared to other countries in Europe, but we are growing very, very fast just because we need to retake to reduce the gap, let's say.
Yeah.
This is not real, this is not true for the luxury car makers, such as Lamborghini, Ferrari, but also Ducati. Ducati is working on a really, really secret project of an electrical motorbike. They are really, really near our offices here in Bologna.
Yeah.
We know them very well. So there is a lot of interest. And so these are really the competencies of the future. Not of the future, of today, that the operators in these sectors needs. So I'm really glad to be here and to know that there is an international academic training course dedicated to these thematics, to these topics.
Yeah, for sure. Yeah. So I think this is the main goal of this winter school. So you mentioned in your presentation, correct me if I'm not right, if I'm wrong, you have some, let's say, academic collaboration with the University of Bologna.
Yes, of course.
And do you have another collaborations with, for example, L'Aquila university?
Sure, for sure. In our network, there are several historical partners from the academic side, from the university. One of them is University of L'Aquila, with which we are actually working together inside some projects, some Excel project. It's called, for example, Comfort Drones, and is related to the drones, of course. And we are proficuously collaborating with them, of course, with Stefano Di Gennaro.
Yeah.
So, yeah, we know each other very well. And there are other, historically speaking, partners coming from universities, such as University of Cassino. But of course, University of Bologna, University of Modena, University of Parma, with which we have the collaboration with a spin-off of the university that is called E-Drive Lab, that works on electrical vehicle. And we work with Politecnico di Milano. We are inside 2 of the 9 competence centers in Industry 4.0. So, of course, we are talking about the enabling technologies of Industry 4.0, but that are really interesting also for automotive sectors. And in fact, we are talking with them to develop a training path inside the competence centers, totally dedicated to electrical vehicles.
Yeah. Yeah, nice to hear from you this point of view. Do you have the possibility for our students to offer them internships in your company in collaboration with L'Aquila or academic university partners of this master?
Yeah, for sure. We are working on it. Actually, it's quite recent. It's quite recent just because in our model up to 2 years ago, we didn't use the internship in the collaboration with the university done in this way. But it's quite recent, the new that we started with 2 internships actually in Italy. We started with University of Cassino on electrical vehicles, but of course we are intention to enlarge the number of collaborations.
Good.
And so from one side, the collaboration with the researcher coming from university is important just because the number of R&D activities we are doing is growing, fastly growing. So yeah, essential. On the other side, we are really also interested in employing people. Yeah. The objective of the last project I showed you, one of the target will be to have 30 new employees, mainly coming from university masters or coming from university with a master degree.
And for this point, it's very interesting to hear you from this point of employment. So you said the levels of employment can be master or engineers. And do you have a level linked to PhD, for example?
Yeah.
You have some collaborations with the PhD thesis and so on.
Yeah. Yeah, we are talking mainly about STEM, S-T-E-M, of course, universities, so technical one, but not only engineering, also physics, mathematics, and so on. Also statistics is important for the data science part. Of course, we will perform before a period of training in order to make the new resources able to work on the project, to be active on the projects, yes. And mainly we are looking for guys that has resources that has at least a master degree. Of course, the project you have, so the university you are following is one example of what we are looking for.
Okay, yeah. Thank you for all this information. Very important information.
You're welcome.
For our students. So for our students, so I think you can, if you want to ask questions to Moody, so you have to write them directly, and they will respond to you by emails. I think it's a good way. So, but when you
for sure.
So some of students will go to the L'Aquila University, and maybe there will be
we will keep in touch with
interact with students and so on.
For sure. Thank you so much.
Okay, thank you very much for you, and see you next time. We hope to see you next.
For sure.
Next for the next event of the master.
Yeah, for sure. Again, thank you so much for the invitation, and have a great day and a good job.
Yeah, thank you. Thank you, you too.
Bye-bye.
Bye-bye.